Okay, so practice M2. Here's exactly what it'll look like. So here we go. Graph the linear equation. See multiple choice graphs? So you have your Scantron with you, right, tomorrow night? And multiple choice graphs. So how do you take minus 4x minus 8y? Let me get that over here. Minus 4x minus 8y equals 16. And, graph it. What do we do? Good memory. Yeah. So first step, let me write over here. First step, get y alone. Yeah, got to get y alone, exactly. All right, so what do we do to get y alone? Y is over here saying, I want to be alone.
Send the 4x.
Yeah, so add the 4x to both sides. Boom, boom. That cancels out, okay. And then we get minus 8y. Now, what do I do on that right side when I add that 4x? Does that become 20x? 16 and 4, 20x?
No.
No, they're unlike terms, huh? Right, if that was 16x and 4x, then yeah, they'd be 20x. But they're unlike terms. They cannot add. So I'm going to put the x in the front. You could put the 16, but it's typically, if people put the x in the front. It's what you usually see. So I'll just put the x in the front. But again, they can't add. They're unlike terms. Now, y is still saying I want to be alone. So what do we do? Divide by negative 8. By whatever's in front of y, huh? And whatever you do to one term? All three. Negative 8, negative 8, negative 8, right? Because you got to do all the terms on the left and all the terms on the right. Treat them exactly the same. Two things were equal before. Treat them all the same. They'll be equal afterwards, huh? All right. And then these cancel. And so y equals. Now, what is 4 divided by negative 8? We're going to have to simplify that a little bit. Yeah. Right. Yeah. 4 goes into 8 2 times, huh?
It's 1/2.
So it's going to be negative 1/2 x. Does everybody see what happened there? Let me go slow right there. See, 4 went into 8 2 times, and there's a negative. Now, remember, with a negative on a fraction, doesn't matter where you put it. My usual habit, and I think it'll be helpful to you, is to put it right in the. I'm going to put it in the top, actually. Because I'm about to graph. Well, yeah, you're right, Dennis. I do often put it in the middle, don't I? Either place. I'll just put it in the middle. Whatever. Top, bottom, front. It doesn't matter. It's all the same thing with fractions negative. Now, what about the back 2? 8 goes into 16, 2. This time, the 2's left on the top. See the difference? With that first fraction, with this fraction, the 2 was left over on the bottom. The number on the bottom was bigger. The 8 was bigger, huh? So the 2 was left over on the bottom. But in the second one, the 16's bigger. The top's bigger. So the 2's left over on the top. What does that mean? Well, it's just a plus 2. Actually, it's minus, isn't it? Because, again, we have a minus sign somewhere on the fraction, so it just makes the whole thing negative, doesn't it? So do you guys see why the front one is negative 1/2 and the back one's negative 2? See, it's all about where that 2 was left over. In the front fraction, again, the 2 was on the bottom. The bigger number's on the bottom. On the back fraction, bigger number on the top. 2's on the top. It's really 2 over 1, but we don't show 1's on the bottom. But we do leave 1's on the top, like in that first fraction, don't we? Good to there? Now we're ready to graph it. Okay, great. So we got y alone, step 1. Step 2, how do we actually graph? I'm going to do step 2 in here. What's that? Yeah, exactly. This number, huh? Start on the y-axis, the middle line, with that. So I'll just do one right here. You go down to, put a dot. Everybody good there? That's going to be where the first dot goes, down to. Let me make this a little nicer. 1, 2, right there. So that's your first dot. Whatever number is off to the right, that's your first dot, isn't it? We just need 2 dots, and we'll have our line. So we're halfway there. First dot is whatever number is off to the right. That's always on the y-axis, right? Because the x-axis is the sideways one. The vertical one, the middle line, that's the y-axis. We start there, down to, and then where do we go from there? How do we find the second point? Yeah, you take that negative sign, and I'm going to put it on the top. You could put it on the bottom. It doesn't really matter. But my habit, I think I recommend it to you, is put it on the top. Yeah, remember exactly. Slope is rise. Overrun. Yes. Let me get rid this mess here. So rise over run. So that means from the first dot, not from the origin anymore, but from the first dot, I'm going to rise -1. How do you, what if I said that plane rose -1? How do you rise negatively? It goes down. So starting from here, it goes down 1. That'd be the -3. And then runs 2 over 2. 1, 2. Everybody tracking with me with what happened there? And then just connect the dots. And then I'll find which one looks like that. But did everybody see what I did? So I started with the number off to the right, down to right in the middle line, the y-axis. That's called the y-intercept. And then from that dot, not from the origin anymore, but from that dot, down 1 over 2. Any negative on a fraction, I just throw it on the top. You could put it on the bottom, it would work too, but I just put it on the top. So I go down 1 over 2 and find my second dot right here. So I got my 2 dots, connect your 2 dots, you got your line. So which of those 4 looks like that line? Yeah, D, because it's this one, huh? Because he's going through down below the axis at -2 and then goes down to the right. Yeah. And he goes, yeah, it looks, if you count the dots, I'd have to make it, you have to look closer. But you can tell it does go down 1 over 2. There it is. Is that good? Feel like you'll be able to do that on the exam for the big points? Questions I can answer on that one? Okay, next, find the intercepts. So we have 3y is -6 plus 2x. And then you got all these things here. So what do they want me to do? How do you... Intercepts come from making one letter 0. Remember that? So in other words, to find an x-intercept, set y equal to 0. So I'm going to take that equation, and then when I'm done with that, I'm going to come down and I'm going to find the y-intercept by setting x equal to 0. Vice versa. You set the opposite letter to 0. Remember that? For an x-intercept, you make y 0. For a y-intercept, you make x 0. And then you just solve the equation. So I'm going to take this equation, 3y is... So I'm going to end up solving this equation twice. And I'm going to make what 0 in the first one? Y. I'm going to take that 0 and plug it in right there. For y, so 3 times 0 is -6 plus 2x. That means 0 is -6 plus 2x. So far, so good. I just plugged in 0 for the y. Okay, now, let me bring it up here. 0 is -6 plus 2x. Now, sometimes when... Make sure you keep the 0 over there. I've seen students in the past, when one side becomes 0, they kind of lose it, and then they lose the equals, and they kind of get frozen. They don't know what to do. No. 0's a number. 0's a number 2. Just keep him over there. Keep the equal sign. Keep right on rolling. What's going on? What are we doing? Same thing we're always doing. X is yelling out, I want to be alone. So don't let the 0 freak you out. That's what I'm basically saying. Just keep right on moving. Exactly what we always do. X wants to be alone, so what's my next step to get X alone?
Send the +6 over.
Yeah, add 6 to both sides. That's gone. And so we get 2x equals 6. Last step to get x alone? Divided by 2. 6 divided by 2 is 3. So that's x is 3, y is 0. I'm going to find the other one. But right now I've got 3, 0, which would be this one or this one. It's one of those two, isn't it? Already I know it's either B or C. Does that make sense? Because they both have this 3, 0. This is x is 3, and it came from y is 0. So it's 3, 0. That's the x-intercept. Now let's find the y-intercept. That one will be easier. So again, take the equation. Start with this same equation. 3y is -6 plus 2x. Same equation. This time, plug in 0 for x. So we get 3y is -6 plus 2 times 0. 3y is -6. 2 times 0, that's just 0 gone. Y is saying I want to be alone. Divide by 3. Y is is minus 2. So that's y minus 2. It must be answer C, huh? Because that came from x0. That's 0 minus 2. It came from x0, x, y. 0 minus 2. We good? Questions I can answer on this? So you want to put on your 3x5 card? Intercepts. So right now, so again, a good question I'm asked. People say, how do I make the card? Make it right now. Even right now, even if you don't have a card with you, just on a separate piece of paper, start writing the things you're going to want on your 3x5 card. And that would be anything you need on the practice exam. So it's different for everybody. But it's whatever you feel like you need to remind yourself, because it's going to be exactly these problems on the real exam. You're seeing exactly what the real exam is going to look like. So whatever you need to remind yourself, you might need the whole example, for really hard ones, or maybe just a note that says intercepts, set each letter to 0, right? X-intercept, set y to 0, y-intercept, set x to 0. That's probably enough right there. If you just put intercepts, boom and boom. Just like that. That makes sense? All right, any questions on this one? Let's go to 3, huh? Find the distance between the points 3, -7, -2, -10. Okay. All right, so number 3. What was it? 3? I already forgot. So there it is. And what do they want? They want us to find the distance. So find the distance between those points. So it's all about having the distance formula. So what, anybody remember the distance formula? Distance equals x1 minus x2 squared plus y1 minus y2 squared. So there's another one. Put on your 3x5 card, right? That distance formula. Don't be tested without it. All right. So now what are we talking about the x1, x2? You remember all that stuff? You comfortable with all that? This is x1, y1, x2, y2. Right? Points are always xy, xy. And then there's the x1, y1, x2, y2. So plug those in. Can you do that? If I can help. Okay, so this is square root of, it's going to be x1, 3, subtract x2, -2. See how we got the double negative thing there? Because the subtraction from the formula, the distance formula, and then x2 is negative also. Plus y1, -7 minus y2 minus 10 squared. Like that. It's a square root of. You know the double negative here becomes positive, and the double negative here becomes positive, right? So we get 3 plus 2 squared plus -7 plus 10 squared. That good? Double negative head-to-head becomes positive. Both of them did. And then square root of, and that's going to be 5 squared. What's that? 3 squared. So that's 25 plus 9. Square root of 34?
Yeah. I have a question.
Yeah. For the, the order actually doesn't matter on these because, and here's how you can know. It's just two things subtracted, right? So does the order of subtraction matter? Like if I go 7 minus 9, is that any different than 9 minus 7? Well, yeah, it is. This is minus 2 and this is plus 2, huh? Then why am I saying it doesn't matter? Because it's squared. So you see, if you take this and you square them both, then in the end, you see how they're both just going to be positive 4. Yeah, the order in this formula doesn't matter because in the end, they're just squared. If you switch the order, it just changes the sign, and the sign doesn't matter because they're all coming out positive anyway. They're being squared. So good question. It doesn't matter on this formula. Some other formulas it does. So again, if you switch the order of subtraction, that just changes the sign of the answer. But it's being squared, so it makes no difference for this formula. Good question. Go back to the thing. So square root of 34. There it is. Answer A. All right, on we go to B. Solve using addition and multiplication principles together. All right, so let's try that one. So this is 2/5 x minus 1/3 x equals 5. Yeah, just multiply those. You take aim at those two denominator pieces, huh? And so the LCD, I'll do it here. LCD is 15. Yeah, what you do is you multiply through by LCD over 1 every term, huh? LCD over 1. So it's going to be 15 over 1 in the left, 15 over 1 in the middle, and 15 over 1 on the right. And then go through and cross cancel whatever you can. Okay, yeah, so and then we cross cancel, huh? So this is what we always do for the LCD is 3 times 5, 15. And then we cross cancel. 5 goes into 15 3 times, and you multiply whatever's left over, don't you? So it's 3, well, I'll just say it's 6x, isn't it? Is that okay? See what happened there? The 3 and the 2 multiply. So you cross cancel, multiply whatever's left over. Minus, same thing here, 3 into 15, 5 times, what's left over? 1 times 5, and then the x. And right now, do I cross cancel 5 into 15 here?
No.
Yeah, why not? Because it's over 1. Yeah, you only cross cancel things under the bar with things over the bar, right? These are both above. They're both on the top. They're going to multiply to be 75. We good there?
Mm-hmm.
They don't cancel. It's only under to over that cancel. So 6x minus 5x? 1x. In other words, just x. X is 75. Oh, none of the above?
Or you could have done, you could pick the 1x over.
What's that?
I just follow the whole thing, just take the 1, put it over there just because. 75 over 1,
Oh, okay.
only because, hey, force a habit.
So the answer is not there, right? None of the above. All right. Want to try number 5? So make it a little bigger here. Minus 3x plus 2 parentheses 3x minus 6 equals minus 2 minus 7x. All right, so we distribute. Boom, boom. And so we get minus 3x plus 6x minus 12 minus 2 minus 7x. Good so far? And then just these two will gather, won't they? 6x minus 3x? Positive 3x. Good. Okay, now we have x on opposite sides. What do we do when we have x on opposite sides? Get rid of one of them, bring them all to one side. So I'm going to do the opposite. I'll go add 7x to both sides like that. Gonzo. And so that gives us what? 10x minus 12 is what? Minus 2. See what I did there? Canceled these guys out. X is saying I want to be alone. Add 12 to both sides. Kind of running out of room there, so we'll get 10x is, what's that, 10? Oh, that's nice. So I'll bring it over here. So 10x is 10, last step. Divide by 10. So x is 1, right? Whoops, there it is, answer C. Answer is 1. Questions on that one? All right, let me jump in and help. So again, how do we find the LCD? You look at the things in the denominator. You take one of each, right? LCD is one of each type. It's like you're going to the store and you're going to buy one of everything, right? So one of each type. So and x minus 3, that's a glued package. You can't separate that. You can't say, well, you You can't think, well, I just need an x and then I need a 3 and then I've got everything. No, you need an x. Yes, you do. But then we need an x and we also need an x minus 3 inseparable package, right? Are you with me on that? Pluses and minuses are the Costco glue, aren't they? They glue things together, pluses and minuses. So that x minus 3 is a package deal. You can't think about the x and 3 separately. Okay, so now what do we do with that? We multiply top, top, top. So I'm going to go x minus 3 in the left, x minus 3 in the middle, x minus, oh, did I write 1? I said 3, but I wrote 1. X minus, and these are all over 1. I just don't have room to write them all. They're all over 1. There we go. Right? X, that's what we always do. LCD over 1, multiplying every term, left, middle, right. Same thing, huh? Same thing as we did in the other one. Bless you. And then we cross-cancel whatever we can. X cancels X. What's left over? 24 and x minus 3. And I'll distribute it in a minute. Minus x minus 3 cancels x minus 3. 24x equals x cancels x. 3 and x minus 3. We good there? No more fractions, huh? Much nicer, no more fractions. And now we distribute. So what do we get? 24x minus 72. 24x, boom, boom. 3x minus 9. So 24x drops out. Right, they just cancel. 24x minus 24x. So then we get minus 72, 3x minus 9. X is saying I want to be alone. So what do we do? Add the 9. And so we get something. What is it? Minus 63? Yeah, that's it. Huh? And last step? Divide by 3. I'm betting on negative 21. X is minus 21. There it is. Minus 21. When you do good work, the answer is always there. Well, actually, no, it's not, is it? Sometimes it's none of the above. So, equation of lines. So, I gave you a game plan for finding the equation of a line. And so, that is, I suggested that you write m, slope, equals y minus blank over x minus blank. Do you remember that? It was like the slope formula with the blanks. Now, I'm sure they showed a different way on the help buttons. I don't care how you do it. I never mind at all. But I found this is easier for students over the years because it avoids a lot of fractions, basically. So I do suggest this way, but I'm fine with any way. And you won't, this is a Mr. Heron special. They don't do it that other way. I did. Just write that. Whenever they say equation of line, there'll be like 2 or 3 of these in a row now. You write m equals y minus blank over x minus blank. Well, actually, first step is you should get a slope. Yeah, let me do a better job in showing all the steps. So step 1 is you got to find the slope, and step 2, when you have the slope, then use m equals y minus blank over x minus blank. Okay, so what is the slope? Yeah, that's the m. They use m for slope, negative 1/3. Some French word from mountainous means slope. So then you grab that, you plug it in over here. So negative 1/3. And then on the other side, we have y minus blank over x minus blank. What do you put behind the y and behind the x? Yeah, this is the x. Remember, x always comes first and y second. So put the 10 here. And the negative 3 behind the y, right? The x behind the x and the y behind the y? That makes sense. This now it's and what do we do now? What do we do when we have 2 equal fractions? Fraction on each side of the equal sign. diagonal. If there's just two of them, you can just go diagonal, diagonal. Yeah, let me clarify. That's why practice exams are good, huh? Because we kind of learn one skill, and then now we're putting it all together. Yeah, so you don't have to do LCD. I mean, you could. It's okay, but it's even easier to go diagonal, diagonal, just cross multiply. Just boom, boom. Let me show you. Back over here, we had 3 fractions. See? If you have 3 or more, I don't think you're going to get more, but if you have 3 or more, you have to do LCD over 1, LCD over 1, LCD over 1. Same thing back here. See, this was 3, LCD over 1, LCD over 1, LCD over 1. But if you just have 2 fractions, you just have 1 fraction on the left and this is all one big fraction on the right, isn't it? If you just have 1 fraction each side, you can save a little bit of work and just go diagonal, diagonal. LCD is still fine. This is just a shortcut to LCD. If you did LCD, you'd get exactly the same thing. This is just a little quicker. Just diagonal, diagonal when you just have 1 fraction each side. Okay, now the question is, though, that minus sign. Who's he going to go with? Top or the bottom? Or both? I'm going to put him on the top only. You could put him on the bottom only, but don't put him on both. Because 2 negatives would actually be positive. So that's the only wrong thing to do, right? Remember, when you have a negative on a fraction, you can put it top or bottom, but not both. I'll just stick it on the top. Again, that's always my habit. And then I just grab these 2. So negative 1, x minus 10. And then I grab the other 2, 3, y minus 3. Is that good there? So see, I just went diagonal, diagonal. It's the same thing as common denominator. It's a shortcut when there's only 2, 1 fraction on each side. All right. And then you know about the double negative. That's just going to be positive here, isn't it? I'll just make that plus. And then we distribute. Minus x plus 10. Distribute 3y plus 9. Like that. And notice all the equations over here. They all have y alone, don't they? So we've got to move towards getting y alone there. So what do I do to get y alone? Subtract that 9. And we got minus x plus 1 is 3y. Last step. Divide by 3. So which one of those answers is right? B, it is. Right, minus x over 3, that's just, you could put a 1 on the top, it's the same thing. Right? Equation. So, all right, so whenever you see the words, find the equation. You'll see it 2 or 3 times on the exam we're going to take Thursday. First step is get a slope. And then second step, after you have a slope, the second step will be m equals y minus blank over x minus blank. Right? That's the same 2 steps I wrote back here, wherever that one was. So same 2 steps. These are the 2. Good idea to put this right on your 3x5 card. When you see the words find the equation, be at least 2 of these on the exam we're going to take. You first find the slope, and then step 2, write m equals y minus blank over x minus blank. Okay, so how do we, last problem, I'm going to go back to it, it was number, this one. Yeah, there it is, slope first, and then the m equals y minus blank over x minus blank. On that one, they handed us the slope, didn't they? Right here, silver platter. They just gave us the slope. Here you go. Negative 1/3 is the slope. That was nice. That was an easier problem. But now on number 8, they're not handing us the slope. So we got to get our own slope. How do we get the slope? Yeah, it's basically like that equation down there, but it's the y2 minus y1. It's kind of like the distance equation a little bit also, but doesn't have the square root or the second powers. It's the slope equation. It's like the one so we're going to basically use this m formula twice. Once with the 4 numbers plugged in, and then the second time with the blanks at the back with the 2 numbers. Remember, there's 2 different ways we use that formula. So we're going to first use it with all 4 numbers. Remember how this works? This is x1, y1, x2, y2. Right, so for a point, xy, xy. So take y2 minus y1 over x2 minus x1. Then reduce that fraction. You'll have your slope. And once you have your slope, then use the same formula we used last time. Okay, so let's try it. So y2, so watch the order we have up there. y2, that's minus 39, subtract y1, which is minus 44. So watch the little stuff. Subtractions, negatives, right? You see those right there? What's that? Yeah, order of things, right. On the bottom, x2, 8, subtract x1, 9. Is that good? And then, double negative here. It's going to become positive, isn't it? So it's minus 39 plus 44 over negative 1, which is 5 over negative 1, which is negative 5. So there's the slope. That's the end of step 1. The slope is negative 5. And then I go into part 2, and I just use the slope formula again. But this time with the blanks at the back, right? See how this was the full-blown slope formula? And here now I'm just using it with just blanks at the back. I'm not going to plug in all 4 numbers, just 2 numbers. And you can do whichever 2 you want. You can do these first 2 or the back 2. It doesn't matter. So I'm going to just do the first 2, I guess. So I'm going to put the x behind the x and the y behind the y. But again, there's subtractions in the formula. That's in addition to any negative numbers, okay? And then I'm going to grab this negative 5, because that's m. Yeah. So negative 5 equals, that's going to be y plus 44 over x minus 9. Make that a little better. We get to there. And now, put this over 1, right? Any whole number is really over 1, isn't it? And go diagonal, diagonal. Cross multiply? Questions? So now we cross multiply. We'll get negative 5 times x minus 9, 1 times y plus 44. Everybody see what I did there? Just diagonal, diagonal. And then you distribute. Minus 5x plus 45. And distribute y plus 44. Y wants to be alone. If you look at all the multiple choice answers, they all have y alone. So we got to get y alone. So we subtract 44. Y equals minus 5x plus 1. A loaded moving truck is traveling 20 miles per hour faster than a freight train. And the time it takes the train to travel 120 miles, the truck travels 200 miles. Find the speed of the truck. All right. What is our formula? The dirt. Distance equals rate times time. That's right. Distance is rate times time, the dirt formula. So remember, we set up 6 boxes, 2 under each letter. Remember how these work, these travel ones? So good to put a whole example maybe of one of these on your 3x5 card. All right, so coming up here, step number 1. Get 4 boxes from the words. So take the words and from them get 4 boxes. Here we go. The loaded moving truck is 20 miles per hour faster than the freight train. So one of these is going to have to be the truck and the other the train. Remember how this works? Say I put a 10 there. What does that mean? That would mean that, the distance for the truck was 10. If I put a 10 down here, that means the distance for the train was 10 miles. If I put a 10 over here, that means the time for the train was 10 hours. Put a 10 here, that means the rate for the train was 10 miles per hour. Right? Getting the idea? Okay. So, what are they saying? The truck is 20 miles an hour faster than the train. The truck's 20 faster than the train, but I don't know what the train is. Somebody would just tell me the train, like maybe the train's going 40, then the truck's 20 faster, the truck could be going 60, but I don't know what the truck's doing, or the train's doing. The truck's going 20 faster than the train, but I don't know what the train's doing. X, right. The truck is 20 faster, so the truck is X plus 20, and the train is X. Those are both rates, by the way. They go in the rate boxes, the middle boxes, right? Speed is rate, miles per hour. See how the truck is 20 faster, so X plus 20? Is that good? In the time it takes the train to travel 120 miles. 120 miles, is that a distance, a rate, or a time? It's a distance for which one? The train. The train covers a distance of 120 miles. The truck travels, that's the distance for the truck. He goes in that's in the same time, right? Because the truck's going faster, so he covers more distance in that same time. We good to there? So notice we have 4 boxes. That was step number 1. Get 4 boxes from the words. Check. Got it. Got our 4 boxes. Step number 2. Other 2 boxes from the relationship distance equals rate times time. Remember, those letters up there aren't just decoration. Right? They're defining a relationship. Distance is equal to rate times time. So, okay. So, how do I get those other 2? Those other 2 are time boxes, aren't they? How do you find time? You take this equation, isn't it? It's an equal sign. Here's the wall of separation. I want time. That's what I need. I need those 2 time boxes. I want time. So if you take that D equals RT equation, and T's saying, I want to be alone. I want to find time. How do you get T alone there? Divide by R, right? So time is D over R, isn't it? Time is distance over rate. See that connection? So if you want this time box right here, you take the distance over the rate. 200 over X plus 20. You want this time box down here, you take the distance for that train over the rate for that train. See how we came up with those? Because time box is distance box over rate box. The left over the middle. The left over the middle. Distance over rate. We just solve for T then. That's how you get the last 2 boxes. Is that making sense? I think this may be a different type than we did in the homework. I don't think we had to solve for T like this. This is a different brand of travel problem I'm bringing you here. We did some travel, but not quite like this one, I don't think, where we had to solve for the T. Does that make sense? So first step, get the 4 boxes, then get the other 2. You got to solve for the other 2. Now, okay, so there's one more step. Step 3, remove the last 2 boxes and write some kind of equation. So that means this box and this box. I don't care about the other 4 anymore. Just grab those last 2. So this is generally how all these travel problems go. Use the dirt equation, 6 boxes, 2 under each letter. Step 1, get 4 boxes from the word. Step 2, get the other 2 boxes from the relationship, D equals R times T. Step 3, pop out those last 2 boxes and write some kind of equation. Now, what kind of equation should I write? You know, sometimes we add them up to equal some number. Sometimes we subtract them. Sometimes we just set them equal. Which one is this? Now, how do we know? Any ideas? Is this a time? How do you know? Beautiful. Beautiful. Right? He's right. It's coming out of a time. They're both coming out of time boxes. Yes, they're time. I don't care how weird they look. They're a formula representing time. They came out of a T box, right? They both came out from underneath the letter T. We are time. Don't forget. We are time. So there's some amount of time. They represent time, don't they? Okay, and then what else did you notice about time? What do the words say about time? In the time. What does that mean? In the time. In the time it takes the train to travel 120 miles, the truck travels 200. In the time. When we use that phrase, what do we mean? In the time it takes us to have this class, whatever, some big sports event's probably going on. It's in the same time. That's just English language, same time, isn't it? In the time means in the same time. So they're saying these two times are what? Same. Yes, they're equal. That's what they're saying. They're saying it. They're even saying it in the language we speak, English language. But it's a little veiled, isn't it? Do you see that? They're saying in the same time. In the same time. So those two times must be equal. Is that good? So now we just solve the equation. How do we solve that equation? What do we do when we got two equal fractions? Cross multiply. Can you whip it out from there? So we go diagonal, diagonal. 200x is 120 times x plus 20. 200x, distribute. 120x plus, what's that, 2400? X is saying what he's always saying. I want to be alone. So what do? We have x on both sides. Subtract one of them. And so this is what? 80x is 2400. And what do we do to finish getting x alone there? Divide by 80. So x is, I don't know, 30. Thank you. So x is 30.
Answer on the exam was 50.
What?
You had 20?
So we got the wrong answer?
No.
Just forget about everything I just said then. I'm sorry, I'm just joking around. No, yeah, it's really tempting at this point. A lot of times they'll put 30 as one of the answers or whatever, and it's just tempting to grab it. They're being actually kind of nice by not putting it there. Well, wait, what am I talking about? Isn't 30 the answer? We just solved it. Careful. Got to be more careful. You know what a lot of STEM, science, technology, if you want to go to the way of STEM, it's good reading skills. It really is. Really precise, careful, exact, detailed reading. What did they say? What did they really want from us? Find the speed of what? The truck. Well, isn't that what X is? Look at your table. Truck rate. Oh, X plus 20.
So, yeah, 20.
See, you see what's happening there? We can give them anything. Once we have X, so get this main idea with these travel ones. Once you have X, you have the key. You can unlock any door up there. You can give them the distance, rate, or time of the truck, or the distance, rate, or time of the train by just plugging in X. Now the mystery's over. X is 30. You can plug that X30 in anywhere and give them anything they want. But then you got to make sure you give them what they want. What are they asking for? Speed of the truck. So you go find the truck speed box. That's right here. Truck rate, X plus 20. Oh, so they want X plus 20. So it is 50. Watch out. Wouldn't it be a bummer to do all that good work and get to that last step and grab a 30 answer when you were just one step away? Watch out for that. I'm not sitting around trying to trick you like that, but these multiple choice test banks, I get these things from. Sometimes they put those answers there. So watch out. Make sure that you're reading carefully what they're asking for. Just always double check. It's just a good habit if you're going the road of science and technology is to become a disciplined reader. That's true. So 5 over 1 to the left, 5 over 1 to the middle, 5 over 1 to the right. All right, so we cross cancel. So we get 5F. And here the 5's cancel. 9C. And here 5 times 32, 160. No more fractions. See how the fractions canceled in the middle? And the 5 multiplied in the other two places? We good there? Now, there's a couple letters. What letter are we trying to get alone? C, right there. So C is saying, I want to be alone. Get rid of all this stuff so I can be alone. So what do we do next? Subtract that 160. And this other set will be 5F minus 160. And then last step to get C alone. Divide through by 9. Boom. There we go. There's the answer. And it appears to not be there. I'm going to take it back and show you. The multiple choice thing. Let me come up here. I'll solve it again real quick while you guys look and see which multiple choice answer is the right one. I don't want you to be fooled by this. That's why I'm showing you ahead of time. So again, we multiply through by 5 over 1 to the left, middle, and right. And it cancels in the middle, and we get 5F, 9C, 160, and then to get C alone, we subtract 160, 9C is 5F minus 160. Last step to get C alone, divide by 9, divide by 9, divide by 9. So there's our answer, but it doesn't match any of the multiple choice, does it? So we're tempted to grab none of the above, and of course some answers are none of the above. But before you grab none of the above, carefully check those answers. What I mean is, see how these are in a different form? They have parentheses. So they may be the same thing, but they're just in a different form. Do you see that? That's why I'm showing you in advance, so on the multiple choice day you're not thrown off. I don't want to throw you off. I want you to know what's coming so you can prepare. So what we need to do is take this and see if it's really the same as that, or maybe the second one's the same, or maybe none of them are the same. Well, how do we do that? We'll take it over here and take 5/9 times F minus 32 and distribute that, right? Anything in front of a parenthesis distributes, right? What would that be? 5/9 F minus 5/9 times 32. Good so far. I just distributed that 5/9 to make it look more like this one. I want to see if they match. See if there are different ways of saying the same thing. 5/9 F minus. Now, how do you do a fraction interacting with a whole number? 5/9 multiplying 32. How do we do that? Put the 32 over 1. Huh? Any whole number is really over 1. 5 times 32. Oh, we can't cross cancel here, right? Because 9 and 32 have nothing in common. So instead we multiply top times top. That's 160. On the bottom, 9 times 1, 9. See, it matches exactly. It's A in a different form. Do you see that? Makes sense? Question? All right. Another word problem. Your favorites, right? Number 11. In a triangle, the second angle is 3 times as large as the first angle. The measure of the third angle is 10 degrees greater than that of the first angle. What is the measure of the largest angle? Well, what I think will help in this case is to write first angle, second angle, third angle. So it says the second is 3 times as large as the first?
So you can do x for the first.
Yeah, 3x and x, huh? Does that make sense? The second is 3 times as large as the first. Can you take it from there? So what's the third angle? 10 greater than the first? X plus 10. And then these 3, x plus 3x plus x plus 10 must make 180. Right? The 3 angles in a triangle always add up to be 180. We good there? Add them up. 1x, 3x, 1x, 5x plus 10 is 180. See what I did there? I just added like terms. 1x, 3x, and 1x, 5x plus 10 is 180. X wants to be alone. Subtract 10 from both sides. 5x is 170. Last step. Divide by 5. X is 34. Now careful again. X is the key. We can unlock any door now, but let's pay close attention to what door they want. What door do they want? Largest angle. What's the largest one?
Largest one would be 3x.
Which is 100.
Yeah, probably so, huh? So, yeah, let's go back. So x is 34. 3 times x, 3 times 7 is 90. Oh, yeah, 102. And this is x plus 10. 34 plus 10. That's 44. So the angles are 44, 102, and 34. So what's the largest? 102. 102. There we go. Okay, so number 12. 6 minus the square root of minus 49 plus 4 plus the square root of minus 9. Do you remember? What is a negative inside of a root? Kicks out an I. Right? Yeah. So you take this negative and you kick out an I just to the front of the root, huh? Same thing here. This negative, kick out an I just to the front of the root. So we have 6 minus, and then what's the square root of 49?
7.
So that's 7i plus, and what's the square root of 9? 3i. And now we're going to combine like terms. Everybody good so far? That makes sense. So a negative in a root kicks out an I, doesn't it? Now, is this multiplication? Because there's parentheses. No, so careful. It's still just adding, isn't it? Don't let those parentheses fool you. There's a plus sign in the middle. They're added. So I'm just going to go 6, add 4, 10, negative 7i plus 3i, negative 4i. And there we go. 10 minus 4i, and it's answer B. So this 9 will go to both. So 36 minus 45i, boom, boom, plus 36i, minus 45i squared. Is that good so far? Just first to both, second to both. Now these two are like terms, aren't they? Be minus 9i. Choose your calculator. And then remember what always happens with I squared? Yeah, I squared is negative 1. So we put in a negative 1 there. So that'll be minus 45 times negative 1. And that'll be 36 minus 9i plus 4. And you can just jump right to here if you want, you know. It just always changes the sign on whomever it's with because it's a negative 1, huh? And then 36 and 45 are just plain old numbers. They can add now. What do they make? 81?
Yep.
81 minus 9i. Hopefully that answers there. Yeah. It is.
Multiply by the
By the what?
conjugal.
Yeah, that's it. Yeah. So when you have I and plus or minus in the denominator, or if you have a root or an I, either one, and a plus or minus, you've got to multiply by conjugate. And what's the conjugate? Same as the denominator, opposite sign in the middle. So I'm going to multiply by 5 minus 7i over 5 minus. Conjugate top and bottom, which is the same as the denominator, but opposite sign in the middle. So you got to multiply top and bottom by that. All right, so first to both, second to both on the top and the bottom. So, hey, could we guys go just go diagonal? Could we just do it that way? No, but I want you to see that. That's what's so valuable about practice exams, because we've had all this individual homework where you do the same thing 10 or 20 times in a row, and you feel like you really know it, but you don't really know it yet until you're able to do it when it's mixed up with everything else. So that's why practice exams are super important. That's why I give you 2 of them. And you just need to spend a lot of time on it. Here's one good example. Why can't we didn't we do that in others? We had the 2 fractions and we'd go diagonal. Couldn't we do that here? No. Look back. And here's what I had to do. I think this is what everybody does to get ready for math tests, hard math tests. I would look at something like that and I too would go, well, yeah, why can't we cross multiply? 2 fractions, did we do that before with 2 fractions? I go, let me look back at the 2 fractions, because I know we did it somewhere. Where did we do it? We're right there. Right. Right there, see? We're doing it right there. What's different? Equal in the middle. That's huge. Small symbol, giant meaning. So that needs to become a divide in your mind. You need to start thinking of all of our math problems as either equals kind or no equals kind. That's 2 totally different worlds. There's things we do with equals that we would never do without them. Why? Well, because if you have an equal sign, you have the left and the right that are equal. You can do anything you want, as long as you do it to both sides. They were equal before, they'll still be equal. If you don't have an equal sign, you have no such freedom. See the difference? Even just logically, do you feel the difference? If 2 things are equal, you do whatever you want, as long as you do it to both sides. If they're not equal, you have no such freedom. See that difference? So anyway, that's just one of a million lessons that come to you as you give your life to practice. And that's what I had to do. Math takes hours and days. And you just have to spend a lot of time looking. Oh, I see. See, there's no equals. See that? There's a times dot. Those aren't 2 fractions. This is not an equation. This isn't 2 things equal. This is 2 fractions multiplying. So we can't do things like that, huh? Instead, we just go boom, boom. First to both. 8 times 5, 40. Minus 7 times 8, 56i. And then boom, boom. Minus 15i. Plus 3 times 7, 21i squared. On the bottom, same kind of thing. Boom, boom. 25 minus 35i. Boom, boom. Plus 35i. Minus 7 times 7, 49i squared. Now remember, this should always happen on the bottom. If it doesn't, whenever you're using the conjugate, whenever you're using opposite sign in the middle, that's why we use opposite sign. So we get one of them negative, one of them positive, and the i's go away on the bottom. That's by design. That will always happen when you're doing the conjugate. All right, so what does that leave us then? On the top we have 40 and minus 56i minus 15. What is that? Minus, I don't know, 71? See, is that right? 70, yeah. minus 21i, just use your calculator. And what do you do with plus 21i squared? Remember what I squared does? Flips the sign, because I squared is negative 1. Minus 21. Down below, 25, and then minus 49i squared? Plus 49. Yeah. And then what do we get after that? 40 minus 21, what's that? 19. And the bottom, 50, 70, 75, 74? 74. Is that how they want the answer? Yeah. That's basically it. You can tell the answer. I'll take it back if it helps. 14, what was that answer again? 19 minus 71i. So we got 19 minus 71i over 74. So if you separate it, it's 19 74ths minus 7 74ths I. Where is that? Was it 71?
71.
Oh, was that? I better be more careful, huh? 70. Oh, 71, yeah. Yeah, and 74 on the bottom, yep. So I just lost it. Traveling back. 71I. Yeah, so it is B, isn't it? There it is. All right.
Yeah, because I was going to ask you about that. Should it be good that we always do it like this?
Okay.
Oh, yeah.
So absolute value, 6x minus 3, greater than or equal to 5. So remember we had absolute value greater, and we had absolute value less. Remember the game plan for those two? There were two different plans depending on that. And you can see here's a greater one, here's a less one. So that's exactly what you're going to see on the exam Thursday is one greater one, one less one. Okay, so how do we always do the greater ones? Remember? Absolute value greater. Step 1, you've got to get it alone. But it already is. See, I'm going to give you ones that are already alone. So you can, my real exams are just like the practice. We did a couple in the homework that were harder. I decided not to put those harder ones on the test. Just the ones where it's already alone. So you don't even have to worry about step 1. Step 2. So what do? We remove, remember? Let's remove the absolute values. You remove them and you say, okay, the inside is less than or equal to the negative number, or the inside is greater than or equal to the positive number. So that's what you do.
Maybe I was doing that. 'Cause, this is what I learned from the class. Don't we go?
Both set of rules right here. If you have absolute value less or less than or equal to, same thing. Again, step 1, get it alone, but you're not going to have to deal with that in the test. Step 2, remove the absolute values. And negative number inside positive. Yeah, that's when we do that. So make sure you know the difference. Put these on your 3x5 card. For sure. Does that make sense? So for the greater, the absolute value greater, remember you have greater number, you have two different answers. And remember in the end how they look? You end up having a negative infinity number united with number to infinity. Whereas on the lesser kind, you end up having number, comma, number. Brackets or parentheses sorted.
Oh, so I still did the same.
See the difference? So there's two totally. So don't do this. Here's the mistake many students have made over the years. They just kind of think about the two numbers, the 5 and the negative 5, and they sort of solve them, but they're not real clear which way the symbols are going and things. That won't work. That's exactly what they're trying to trip you up on. That's the whole ball game, is which way those, not just the solving. I assume you can all solve that easy. It's which way the symbols go, where the negative is, where the positive is, where the infinities are or not, whether it's a triple or a double. That's what matters. That's what you have to pay close attention to. That's what this problem is testing. Can you follow those instructions super close? This is what little engineers and people do when they do things, right? Really precise following. So absolute value greater. So I'm going to try to do it right here where I have room. absolute value greater, what are we going to do? We take the inside and we say less than or equal to -5, or the inside greater than or equal to the positive. See how I followed this and this exactly? I did the inside less than or equal to the negative number, or the inside greater than or equal to the positive. What? Because it was an absolute value greater. It was a greater one. See that difference? It helped to see it the second time. That's why we do practice M's as well. So math is always a little blurry for me the first time. So, and now we just solve both those equations. Add 3. So we get 6x less than or equal to -2.
So which one do we start off with? The one that's exactly the question, and then we go or with the sign turned the other way?
So I just grab the inside, and I do the first one less than
Okay.
the negative number,
Okay, I got it.
and the second one greater than the positive number. And then divide by the 6. So x less than or equal to, and that's just -1/3, isn't it? And then on the other side, add the 3. 8. Divide by the 6. And that's 4/3, right? Divided by 2. Top and bottom. Everybody see that? So which of those answers is right? Well, is everybody with me? I want to show you something this will really help you. No way A and C were ever going to be the answer. Just laugh at those two. Why? Because I'm showing you right here, it's going to have the infinities. It's two complete intervals with infinities for the greater kind. So there's no way it's going to be A and C. Because that's only one interval. Only one interval. It's got to be like B, which is 2 intervals, or D, which is 2 intervals, and has the infinities on the sides, right? That's the form of the answer. Do you see what I'm saying? So if you just have this on your 3x5 card, the form of the answer is going to have the infinities. No way it's going to be 2 intervals with infinities on the edges, negative infinity and positive infinity. No way it's going to be A or C. Just laugh at those two. Go, Mr. Heron, you're just kidding me. No way. So it's got to be B or D, or maybe none of the above. Probably B or D. Which one has -1/3 and positive 4/3? D it is. Does that make sense? That seem a little easier?
You can think of the arrows like just adding like a hyphen to them, and it's going that way, so it'll all be the negative. The infinity will automatically be negative. Right?
Because it's going less.
Yeah, so you just
Yeah.
put it as like an arrow.
Sure. Yeah. Because, anything less, it's going to go towards negative infinity. Yeah. And anything greater, it's going to go towards positive infinity. Yeah. Like an arrow. Yeah, you're right. That works. I like that.
Yeah, because I had to learn about how you put the first one first, because you always supposed to read it from left to right. And that's how I was like, oh.
Well, that's for the lesser one. So now let's do the lesser one.
Because even that one's lesser to the right, too, left to right. Negative.
Yeah, this one is. Yeah.
It's the same thing. 4/3 to the right, and that's how you put it in the thing.
Yeah, right. Oh, gotcha, right. Now for 16, see how 16 is different? Absolute value less instead of absolute value greater. Everybody see that? It's got a less than symbol right here. The absolute value is on the narrow side of the symbol. Up here it was on the wide mouth side of the symbol. See how that's opposite? So then we go, okay. That's one of these kind where we do the triple thing. And the answer is not going to. So right away, look at this guy and laugh. Go, no way. At D. No way. Really? You can go, no. Oh, man, what an easy problem. Look at that. It's not going to have any infinities. They're just joking with us. If you know the form. See how easy. This class is so easy. If you're recognizing the forms. And it's not. We do a lot of hard things. But this problem can be a freebie. You see that? See all these infinities? It doesn't have infinity. It's absolute value less. It's just going to have two numbers. The infinities are for the absolute value greater kind. See that? It's A, or it might be none of the above. So we still got to do the problem, because there are some none of the above answers, right? So let's do the problem. Let's see. So how do you do it? You do it as a triple. You put the inside in the middle, right? This inside right here. And then you put a negative 3 on the left and a positive 3 on the right, right? Negative number on the left, positive number. And then both symbols go which way? Less than. Now, we don't have the equals on this one. There's no bar, so I don't put the bar, right? It was just less.
Yeah, you put 2x plus 3, it's 2x plus 3.
Oh, thanks. There we go. Does everybody see how I just followed the format? Just put the inside right in the middle. Put the negative on the left, positive right. So and now we're trying to get x alone. This out of the way, so we subtract 2, huh? From everybody. So that's minus 5, 2x, 1. Is that good? I subtracted 2 from everybody. Last step to get x alone. Divide through by 2. Minus 5 halves 1 half. Of course that's the answer. We saw that coming. So I don't know it's going to be exactly those kind of multiple choice options on the real test. That was a really nice one. We knew it had to be A, or none of the above. It's A. Holy matters. Yeah, this is an A. So this actually is a tricky question. It's none of the above. It's supposed to be negative 5. I didn't even look close. See, I'm telling you. Watch for the details. Unlike me. I was testing you. Well done. Well done. No, I just messed up. Yeah, thanks. I didn't look closely. It's easy to not look close, huh? Yeah, so this one's none of the above. That's actually a very tricky little question, isn't it? Yeah, that was harder than I was thinking it was. It's been too long since I made these up. I don't remember. I'm getting close to that age where I can hide my own Easter eggs. I forget what I do pretty quick. So does that make sense? So it's the wrong signs there. So that was a try. Let's try number 17. All right. So remember these kind with the x squared? So we have... In fact, I think I'm going to go to a fresh screen where we have some room here. So number 17. 5x squared plus 12x equals negative 3. Okay, so what do we do when we see an x squared question? X squared with an equals. Step 1? Get a 0. Remember, you got to get a 0 on one side. Step 2, you can try to factor if you want to, with the 2 parentheses, or you can use the quad, negative b plus or minus square root of b squared minus 4ac all over 2i. All right, so step number 1, add that 3. Right, because we have to make the right side become 0. So we get 5x squared plus 12x plus 3 equals 0. This is A, B, C. I'm going to dive right into the quad. A is 5, B is 12, C is 3. I'm going to go negative b plus or minus the square root of b squared minus 4ac all over 2a. So, here we go. So, negative 12 plus or minus the square root of 12 squared minus 4 times a, which is 5, times c, which is 3, all over 2a. So And that is minus 12, plus just use your calculator here. 144 minus 60 all over 10. And that's minus 12 plus or minus the square root of, what is it, 84 all over 10. Oh yeah, now we gotta do some simplification work. Everybody good to there so far? So remember what how you do the square root. I'll say or, use that. How do we do the square root? Square root of 84. Remember how that works? You use your calculator to break it down. 2 times 42, 6 times 7, 2 times 3. So it's 2 2s, a 3, and a 7. Remember, use all the little numbers that won't break down anymore. 2 2s, a 3, and a 7. That's the square root of 84. Remember how that works? So I just took the 84 and I broke it down with my calculator. Just start breaking it down. And then 2 2s in. Remember the rule for a square root?
1, 2 out.
2 for 1 deal. Yeah, 2 2s in, 1 2 out. There you go. And then that makes 21, right? 3 times 7, 21. So 2 root 21. So the square root of 84 has broken down to become 2 root 21. So let's put it back into the problem and see what that does. So this becomes minus 12 plus or minus. Now the square root of 84 is 2 root 21 all over 10. Now, can we simplify that at all?
Because it has to go on one side, has to go on the other side.
Are we good all to here? Is this making sense so far? I broke down that root 84 to be 2 root 21. Now, can I just go 2 goes into 10 5 times?
Yeah.
Yes.
Yes.
Just that?
No, 12.
You got to do this guy also. Remember, because of the Costco glue. The plus and minus means you do both or nothing.
Yeah, both of them.
Right? So you do them both. So divide the 12 by 2 as well, 6. So the final answer then is minus 6 plus or minus root 21 all over 5. If this was like an 11 instead of 12, and that's not divisible by 2, then we would stop cold. You can't do anything. It's both or nothing, right? So or basically, how about this way? All three outside numbers have to be divisible by the same. They have like 2 has to go into all of them. And so if you had an 11, 2 doesn't go in. You would just stop right there. But we had a 12, and 2 went into all of them. So we do it. So there's our final answer on that. And that's there. It's option C. Look at the thing. All right. We got a couple minutes. I'm going to move on. All right. All right. So there's 5 here that are not multiple choice that we just have to solve. There'll be 4 on the real test. There'll be 1 less. There's only 20 questions on the real test. There's 22 on the practice. So just a little bit less.
On the real test?
What's that? 20 on the real, and only the last 4 are not multiple choice. Okay, so what do you do when you have something like this, some high power thing like this? Got a factor, right? What goes into all those? 3 and x. Leaves x squared plus 7x plus 12. Remember that? Remember you do the, so that's the first step in factoring. You should do the 1 big parenthesis, and then you try to do the 2 from there. So this is how you handle when you have x squared or x cubed with an equals. Step 1, factor, and that means do the 1 big parenthesis and then do the 2 parentheses, right? So now we can do the 2. X is in the front. What multiplies to be 12? Adds to be 7. 4 and 3, both plus, huh? Okay, now we've got it all factored. What do we do now? Each part equals 0. Yeah, because if a bunch of things are timesing to come out 0, any of them can be 0, right? If I multiply 3 things together, but the middle one's a 0, they're all going to come out 0, aren't they? So if any one of those is 0, it'll be true. So the first one could be 0, or the second one could be 0, or the third one could be 0. So then you just solve each of those. Divide by 3. 0 over 3 is 0. Subtract 4. And subtract 3. There's our 3 answers.
There's a similar one on the test.
When you have x squared and no x to the first, that's what this is. Remember the kind when you have x squared and no x? So see how the only x is under a square and there's no regular x? See the difference? Back over here, well, we had a lot of things. We had x cubed and x squared and all kinds of things. So what do you do on this? You get the squared piece alone. Step 2, root and plus or minus. So this is the roof on the house, up and down the ladder thing. So you just get the squared piece alone, and then you root and plus or minus root. So add 2 to both sides. Boom. Good to there so far. So I got the squared piece alone. I'll bring it down. So I got the squared piece alone, and now what do I do? Root, plus or minus. You put a roof on the house, you got to go up and down the ladder. My dorkiest saying, right? If it'll just dorky enough that you don't forget it. A new roof on the house, up and down, plus or minus. When you put a root on both sides, you got to go plus or minus. All right, and now the root cancels the square. Remember they're opposites? Roots and squares, they're always just the opposites. So that just tears off the shell, out comes the snail, x plus 9, plus or minus root 5. Right, good. So we can break that into 2 equations, huh? X plus 9 is plus root 5, or x plus 9 is minus root 5. What do we do to finish getting x alone? Subtract 9 from both, same thing here. Subtract 9 from both. X is minus 9 plus root 5. X is minus 9 minus root 5. There we go. Now this is an absolute value equals. We had absolute value greater. We had absolute value less. So if you have absolute value equal, what are you going to do? Well, step 1, get the absolute value alone. Let's get the absolute value symbols alone. And step 2, you say inside equal the positive number, or inside equal the negative number. See how we always do this positive and negative thing with absolute value? You have those 2 options. All right, so step 1, get the absolute value alone. So what do I do to get that absolute value alone? Divide by that 4, huh? Like that, right. So that was step 1. We got the absolute value alone. We got rid of the 4 that was with it. And then step 2, we've got to take the inside. We we have to say inside, you can be positive 7, or inside, you could be negative 7. That makes sense, doesn't it? If this inside is plus 7 or minus 7, then the absolute value of it will be regular 7, won't it? See how that's true? Does that make logical sense? Right? This inside can be 7 or negative 7. Either way, the absolute value of it will equal 7, won't it? Those are the two options for that inside. If that inside is 7 or negative 7, either way, the absolute value will come out 7. So then we just solve both those. Subtract 3 from both. Same thing here. Subtract 3 from both. So we get 2x is 4. Over here we get 2x is negative 10. Divide by 2. And we get x is 2 or x is negative 5. Those are our two answers. 2 or negative 5. So 21. 21's the big one. 22 will be quicker. 2 square root 6x minus 8 minus 4 is 8. Yeah, square root problems. All right, square root with an equals. What do you got to do? Step 1, get the root alone. So that's always our first step, huh? Get the thing alone. And then how do you get rid of a root? What's the opposite of a root? 2 power. Remember, 2 powers and roots are opposites, huh? 2 powers and roots are opposites. So you just isolate that root, and then 2 power, and it'll take off the root.
Can you add the 4 first?
Oh yeah, we have to, because we got to get the root alone. Our first order of business, before we do any 2 powering, we got to isolate that root. So add 4 to both sides. Next step. What do we do to get that root alone? Divide by 2. It's 6. So all of that was the work to get that root alone. Now that we've isolated that root, what are we going to do? Parenthesis 2 power, both sides, right? We do the same thing to both sides. And the 2 power cancels the root. We get 6x minus 8. The other side, 6 squared is 36. 6 times 6. And look, it removed the root, didn't it? On the left side. So on the left side, it removes the root. Why doesn't anything get squared on the left? Like, why don't I square that 6 to be 36 or that 8 to be 6? Or why don't I square I squared the number on the right? Why didn't I square the numbers on the left?
Because that's how you get rid of the square root.
Because the root took it out. There's no root on the right side, so the squared had his way and squared the number. But on the left side, the root and the squared eliminated each other. They're antidotes, right? So then we just solve for x. Just add the 8 to both sides. Whoops, that's an 8 there. Getting kind of scribbly. So this is 6x, what's this, 44? Last step. Divide by 6. That fraction probably reduces. Divide by 2. 22 thirds. On that. One more, and we will have done them all. By 22. This is a pretty normal one. I'm just going to distribute. 2x plus 14 plus 11. Distribute 5x plus 20 plus 14. Gather like terms. 2x plus 25. 5x plus, what's that, 34. Get down to here. What do we do when you have x's on opposite sides? Yeah, get rid of one. I'll get rid of the lower one. Minus 2x from both gonzo. So that'll be what, 3x? And x wants to be alone there, so subtract 34 from both sides. What's that? Minus 9. Last step to get x alone. Divided by 3. Do I need to flip the symbol?
No.
When do you need to flip the symbol?
You have to divide
When
by
you put a negative under the bar. I didn't put a negative under the bar. Even though the answer will end up negative, I didn't put a negative under the bar, huh? Now, it's easier to see that answer if you flip it around, huh? Flip the whole thing around. So, that's the same answer, isn't it? Because the X is on the narrow side. I don't care, though. I'm good with either one of those answers. This is not multiple choice, so either one's fine. And there it is.